I will go with area 0 portion. So in this topology 1, 2 and 3, these are the member of area 0. So first I will go with the R1 and recording is on. Here I will use the command show IP interface brief. So you can see that interface is configured according to topology, and the status and protocol is in upstate. If I use the command show IP ospf, so this is not giving any information, that means ospf is not active yet. Show IP route, all this route is directly connected. So I will start the ospf process here. So in order to do this, go to global mode and then give the command router ospf. This will ask for what is the process ID you want to set to identify this process. So it is locally significant number. Here I will say ospf process 1, and now I need to be advertise network. So here, because we know that first 2 octet is common, which is 172.16. so I'm using the approach here, network 172.16, first 2 octet is common, third and fourth could be anything, and this is I'm advertising with wildcard 0 0 255 255. So wildcard is mandatory in ospf during network advertisement. In EIGRP it is optional, and I know that in router 1 actually it is not, because if you see in R1 there are some link is goes to area 1 and area 1, right? So this link is going to area 1. That means I cannot say like this, otherwise it will also run ospf on this link and it will add this link as a ospf area 0, but I want these 2 link is only the member of area 0. So here, according to this topology, this approach is not advisable. So then I will go with specific advertisement, which is 12 and 13. These are the network is the member of area 0. 12.0, this one is the wildcard, this is the member of area 0. Second network 172.16.13.0, and this is the wildcard and also the member of area 0. Now here router 1 is also connected with ISP, but I do not know how to reach ISP network, because do not know how to reach the destination 888. ISP router is configured with 888 IP address, but the router is not pingable, reason being it has no idea. The same approach, I need to be configured static default route pointing to ISP network. So here IP route is the command, and then static default route pointing to the next hop in this example should be 8, and double check you can ping this next hop IP, which is 69.18.8. so it is reachable. That means now I can also ping 88888. It is also reachable. I'm running the ospf process here, show IP ospf interface. This is I can confirm with the help of command show IP ospf interface brief, and you can see because now the ospf is running on this link, these 2 link is participating in the ospf with process ID 1. Both link is the member of area 0, and these are the IP address configured on these link. By default, because the reference bandwidth is 100, interface bandwidth is also 100, so coast is 1. But this is, you can change it according to your requirement. If you set absolute value, that will be the link cost. So suppose if I go to interface gig 03 and I said IP ospf cost is 2. Earlier it is 1, right? Yes. So on this link, because I'm absolutely typing, so now link cost of this interface will be show IP ospf interface brief. This is now 2. So this is absolutely you're configuring the metric for this link. So you can see right now there is no neighbor. Reason being on the other side ospf process is not running. Yeah. So then I need to go to router number 2. So in this topology, for router 2 perspective, gig 0 and gig 2, these two link is the member of area 0. So go to router number 2, and here again I have only the basic interface is configured. So start the process router ospf1, and here I also want to start debug ospf debug IP ospf adjacency. This command will let you know that what is happening in the real time when two neighbor is exchanging their parameter with the help of ospf packet. So debugging is on. I will start process router ospf1. It will say because event is occurred, no such information. So process is on because I'm not debugging any event. Now I will say network. So same approach, because only 2 link is the member of area 0, which is 12 and 23. These 2 link is the member of area 0. The 24 is the member of area 2 in this topology. So then I will say second approach to advertising network, most specific approach. I can also say like this: 172.16.12.2 exact wildcard. Yeah, so this is advertising the IP address. So actually you are sending the link information. In the link you have IP address. IP address contain 2 components, net ID, host ID. But in this case I'm saying most specifically I'm saying only advertise this specific network only with exact this number. If this number is, let's say, 12.3, do not advertise. So more specific approach, more controlled approach to advertising network in OSPF. Similarly, the same approach you can also use in EIGRP, specific wildcard. But this link is the member of area 0.
When we configured on router 1, we advertised 172.16.12.1 and 13.1.
No, so over there I advertise network. I mean root. So in the root there might be 1 to 2, because I said 0000255. Yes. So the last number can be any number from 1 to 254. Okay. In this case last number is only 2 because I am advertising with exact wildcard. I will say last number should be match. If it is other than 2, do not advertise this link to other members. So specific approach. So in this case you can see that there is a neighborship is establishing between these two members, and see what is first is happening. Interface is going up and then they are going into the two-way state. So initialization state is sending hello message. Then what is happening? There is a DR BDR election is happening. So first you can see this is electing itself as a BDR. So first router will say I am the BDR and listening the reply from the member. It is electing DR And the final election of the DR is this link. After doing this election, it is going into the, so from the 2-way we will also see there is master slave, this one, we are the slave, so master slave election, that is happening in the X start. You can see this one,
Yeah.
X start. So 2-way to X start to exchange. In the exchange, it is only exchanging DVD packets, DVD from sending this DVD with all these parameter, and then from exchange to it will go into loading, exchange to loading, loading is done, and final action will be a loading to full. So state is full. So when you see this full, that means both router is synchronized and both have the identical copy. And in these examples, because I have only one neighbor, so do show IP ospf database.
Okay, so we are getting this information because you run the debug command.
Yeah, so this is real time because the debugging is on for to look for what is happening in the real time when this router is discovering for neighbor. So you can see the router to database, Ospf is electing its own router ID with 24.2.
Yeah.
Even though this network is not advertised, do show run, but it is connected with this router. Do show run interface, do show run section router Ospf. This is the Ospf configuration on router 2. I only advertising this network. But which one is the router ID? The IP which is configured with highest IP address, 12.2, 24.2, 23.2. Multiple physical interfaces, router which is configured with highest IP address, that is becoming as a router ID. So if I want to override this behavior, I can set router ID manually. I will say router ID 2.2.2.2. Now it will ask if you want to reflect this router ID in your database, you have to be clear the Ospf process. So this is I can do with the help of command clear IP Ospf process, and then once you clear, it will once again will exchange neighborship, exchange database, and once it is done, show IP Ospf database. Right now it is still in the process. So now it is two-way to this, and show and what is happening, a DVD from, okay, loading is done, and show IP Ospf neighbor. I have neighborship with router 1. This is the router ID of R1.
Yeah.
And for simplicity, I can also
Change the
router ID of R1 by saying router ID 1.1.1.1 and then clear IP Ospf process. Once again election will happen. So here if I see show IP Ospf neighbor, so I can see here right now it will say I am in, so right now it says I need to be declare down the old learn neighbor. So you can see there is a timer is going on, and once it is become 0, entry will be declared cleared, and neighborship is up. And now you can see it is remembering the old DR. See, there is no preemption. Show IP, show IP ospf neighbor. See, so router ID is now 111. By default priority is 1. State is full, that means both is exchanging complete database. And my neighbor is BDR. That means I am the DR. Show IP ospf interface brief. My neighbor is BDR, so I am the DR. This is my state. Now if I want to see the detailed information of this interface, then meaning I want to also confirm what is the network type of this interface, I'm using the command show IP ospf interface without any extra keyword. So this will give me the detailed information. So you can see for this link, for the link number gig00, this is the IP address configured on this interface. This is the member of area 0. This is attached via network statement because network command you are using. Process ID is 1. Router ID of this router is 222, which is you configured manually, and network type is broadcast. So by default this is, because the link is Ethernet, the default network type is broadcast multi-access. Link cost is 1. Then DR, designate router ID is its on router ID 222 with their IP address is 12.2, and backup DR router ID is 111. Interface address is this. By default hello timer is 10 seconds, dead timer is 40 seconds. This is the wait timer when the Ospf is using in the election process of DR and BDR. So waiting for 40 seconds. This is equal to your dead timer. So continuous exchange, and this is you can see neighbor count is 1, so 1 neighbor. Adjacent count is 1, and adjacent with neighbor, which is the BDR.
Can you manually select which router should be the DR?
Which router
Should be the DR.
Yes. So here what I will do,
Okay,
so right now,
excuse me, sir. Maybe even before you do that, okay, like what he asked, you will let if you set the priority value of any router to 0, it will not take part in the election process.
yeah, that will not participate. So this is giving the guarantee that this router will be the DR.
So you can use that approach to keep one router as a DR, right?
Correct. In a multi-access network, you need a one router as a DR. So other you can make according to you set priority 0. So in this case, what I will do, I will be using the same approach because there is no preemption here. Even though you increase the priority, it will remember the old DR. So my approach here, show IP ospf interface brief. Right now this is the DR. So what I want to make router 1 is the DR for this segment. I will go to router 1. I will go to router number 2, and I will go to this link, and we'll say priority for this link is 0. So by default priority is 1, right?
Yeah.
So if I go to this link, interface gig00, I will say IP ospf priority. If I set priority is 0, that means you're giving the instruction do not participate in DR and BDR election.
Okay.
So this will give the guarantee that your DR will be now dr111, dr is 111, elected dr is 111, and there is no bdr.
No, this is not.
There is a bdr because it is not participating. So that means show IP ospf neighbor. Now I can see my neighbor is dr.
Yeah.
And what is my state? Show IP ospf interface brief. My state is drother, other, because I'm not participating in dr and bdr elections, so I'm becoming drother. Show IP ospf database. So you can see now here I have two type of LSA, type 1 and type 2, because in these examples ospf router ID is 222. This is the router ID
Yeah.
of this router. Router link state. This is the type 1 LSA for area 0. And in area 0 I have two router. This is the router ID of R1 and this one is the router ID of router number 2. Each router is advertising their link information. Time to learn information, aging time. Sequence number is indicating how many changes you have done in that neighbor. Checksum is indicating that if there is any error in the LSA, that LSA is not accepted. So it is also checking the checksum. Link count, meaning how many link is connected with router 1. How many link? So here router 1 have 1, 2, and which one? No. In this case, on this link, it says 3 link. Where is that? Link count is 34111.
I think it's only showing the OSPF links.
It's so far configured.
Yeah, it is only showing the OSPF link which is connected with router 1. And if I see show IP OSPF,
With router 8, it's a static route.
show IP OSPF,
So that's very configured SPF link for area 0. So I did not configure SPF link to router 7.
this is the detailed information of a type 1 LSA, show IP OSPF database router, and I want to see the link state ID of 111. So this is giving the information is LSA type is router link, meaning type 1 LSA. Link state ID is 111. Advertising router is also same. Sequence number, checksum, length of the checksum, number of link is 2.
So 1. And then 1.
Link connected to a stub network, which is with the network or subnet. Number is 13.0, which is which portion? 13.0.
1, so router 0.
Yes, the link between 1 to 3, because that is also advertised by the router 1.
Why is it already a stub?
Network mask you can also see. So network number and mask, and metric is 0, it is directly connected. Metric for this link is 2 to reach this network from.
This we set it manually. Oh. We set this metric to 2 manually.
Yeah, because we set metric manually. So from here, so if I go to 13 dot, if you see the 13.0 network from here, from router 2, this link host and this link host, so 1 plus 1
Oh, okay.
cumulative host, 1 plus 1, total metric is 2 to reach from router 2 to this destination. Total metric is 2. This is here 2. So link connecting to a transit network, because it is a broadcast link, and with the DR address is 12.1, IP address of the DR. Then interface address you can also see. So it is advertising link information. So IP address, and see the metric for this link is 1.
Yeah.
My cost to reach this 12.1 is 1. Similarly, if I want to see,
Before I go on,
yeah,
why is the link 13.0 already seen as a stub network?
see why it is showing you the sub network, because there is no other link.
Connected?
There is no other link connected behind this router.
Okay. So it's still C1, C2.
Yeah, so network root ID as a stub network, because there is no other network. Show IP Ospf database. This is your type 2 LSA. Now it is showing the correct output. Link count is 2, which is expecting. Earlier it was showing the old information.
We didn't do any change.
Yeah, so this is automatically set because it was taking time to exchange and then showing the correct output. This is what you're expecting, because on this router 1 you have a 2 link which is participating in area 0,
Yeah.
and in R1 you have only 1 link is participating in area 0 so far. This one is your excuse me, type 2 LSA, which is known as network link state.
Yeah.
And type 2 LSA meaning
Network.
it's showing who is advertised by the DR,
Yeah.
and link ID portion is containing IP excuse me, IP address of the DR. This is the IP address,
Yeah.
and this one is the router ID of the DR. And if you see detail information for this, show IP Ospf database, then network. This is network LSA, which is type 2. Now in these examples, if I do not want to deal with DR and VDR, so I can also change network type point to point. So I don't want to say this type 2 LSA in order to remove the additional overhead. Reason being, although the media is Ethernet, but it is directly connected between 2 nodes, so there is no need to be run type 2 LSA here. It is additionally increasing the overhead. But here if you see the detail output, you can see it is indicating who is attached with me.
Yeah.
Attached router with DR. So 111 and 222. So link state ID, mask, and attached router 111 222. If there is other member, so that is also visible here. 2 3 4, all this. But here if I want to remove this type 2 LSA, so what I will do, I will simply go to link number 800 and will say IP Ospf network point to point. So once I change network type, make sure you are setting the same network type on the other side. Otherwise what will happen in this case, you may get neighborship is up, but there will be no database exchange. So network type also must match. On the other side 1, and go to the interface, which is gig/2. Interface gig/2 IP Ospf network point to point. Now each point to point link is counted as 2. One is as a stub and one is actual IP address. Each point to point link is counted as a 2 in the Ospf database. So if you look for here, show IP Ospf database, I don't have any type 2 LSA. And see, each point to point link is counted as double. So clean up database exchange, cleaning, and I'm expecting here 3 count. Sorry, show IP ospf database 3 count. Yes. Okay, so 3 link now connected with 111, 2 for point to point link, 1 for your Ethernet link.
Okay, so it has been changed from a normal Ethernet link to the point.
Yeah, so since it is the point to point link now, each point to point link is counted as a 2. So this gig slash 2 1, this is also counted as a stub network, and the second is point to point link. So 2, and this one is 1, 2 plus 1 3. So 3 link now participating in area 0, which is connected with R1. So continue with.
If you want to revert this, because it's also changing accounts, if you want to revert it back to the default network instead of a point to point.
Okay, remove this command. So if I say gig interface gig slash 2 and no IP ospf network point to point. Okay, it is like this, it is not like this, it is like this. No IP ospf, or if I simply remove this, no problem. No IP ospf network, it is going to the default state. Do show run interface gig 0 slash 2. Do show IP ospf. So default network type is broadcast.
Okay.
So network type is broadcast. Go back to slink interface gig 0 slash 0. You can say no, or you can also set network type accordingly. So here I'm setting no, it is going to the default state. Yeah, so because you already have configured the command show run interface gig slash 0, because it is configured with IP ospf priority, this is not participating in DR VDR election, so router 1 will be the DR. So router 1 is the DR and you are the DR other.
Yeah.
Show IP ospf database. Now you will also see type 2 LSA. So there is a type 1 and type 2 LSA. Okay, so continue with next configuration. So basic configuration now, it will be the repetition of command. Yeah, so the second link, which is router ospf1 network 172.16.23.2. This is the member of area 0. The interface is going up. Go to router number 3, and in R3 these two link, which is 13 and 23 network is the member of area 0. Start process. Router ospf1 network 172.16.13.0. This is wildcard, and that one is the member of area 0. 172.16.23.0. This one is the wildcard, area 0. That one is single area configuration.
In this case, you use change period at 0. Okay. You specify that's 255.
Yeah, so for router 3 perspective now, you're expecting 2 ospf neighbor which is participating in ospf 0. Show ip ospf neighbor. Okay, so 222 and 111 both is the dr. Then continue with rest of the configuration. In this case,
Can
One
we set
second.
the router
So
ID
it means when you
of
set the router to be not participate in their selection, it was just for the 12.0 link.
this is also participating in dr link. Why?
No, I'm saying when you set router to
priority?
priority, OSPF priority to
Because
zero,
I'm
it was just not to participate
yeah,
for
do
their
not participate in
selection for
DRB
one link.
election on that
On
link,
that.
Oh, okay.
because this is broadcast multi-access network and DRB election on per broadcast basis. So this is my broadcast link 1, broadcast link number 2.
Okay.
So on each broadcast there will be a separate DR and BDR.
Okay.
Now on router 2, if you look for router 2, there is one link is going to area number 2, okay, which is 24.0. So how to advertise this? You will say network 172.16.24.0 and this is the member of area 2. So the moment you add one more additional area, this router is now also act as a AVR. Show IP OSPF border router. This will say right now, this will say I am itself the border router, so there is no output. Inter area route. Okay, so show IP protocol is the command which will say it is an area border router, because some link is the member of area 0 and some link is the member of area number 2. Next, go to router number 3. This link gig 1 is the member of again area number 2, which is 35 network. I can also say like this: interface gig 0/1 IP OSPF1 area 0. So you can also advertise or configure OSPF on per interface basis. Go to router number 4. And in R4, how many link is participating in area 2? 2 link,
Yeah.
gig 0 and gig 1. So 24 and 45. So go for R4 router OSPF1 network 172.16.24.0. This is the member of area 2, network 172.16.45.0. This is the member of area 2. Go to R5. Again 2 link is the member of area 2. So start process. Router OSPF 1 172.16.35.0. This is the member of area 2, network 172.16.45.0, and this is the member of area 2 also. Now I am expecting for router 5 perspective 2 OSPF neighbor. Show IP OSPF neighbor is the command. To confirm that, I can see I have only one neighbor, or there is no other neighbor. So start from show run show run and look for the OSPF configuration. Show run section router OSPF. Both network is advertised, which is expected, so configuration is correct. Then look for show IP interface brief. So I have 35.5, 56.5, but this IP is not configured on gig/1 on R5. So IP address, which is 172.16.45.5. No shutdown. Go to R4 and also confirm the same thing. Show IP interface brief. Again, IP is not configured on this link gig0/1. So give IP address by using the command 172.16.45.4, and now you will see the neighbor ship between 4 and 5 as well. So router 4 is now expecting 2 OSPF neighbor. Show IP OSPF neighbor. So right now it is in two-way state. From two-way to, it will go into X start to exchange to loading to full, and once it will do all this, you will see the state will be full here within a moment. So it is going in X start, from X start to full state. So
as we did for routers 1 and 2, can we just similarly set the router IDs of 3, 4, 5, 2?
Yeah.
For uniformity?
Yes.
Identification.
Router OSPF1, router ID 3333, clear IP OSPF process. Also go to 4, router OSPF1, router ID 4.4.4.4, clear process, clear IP OSPF process. Go to 5. So router ID must be unique when you're setting manually. If it is duplicate, there will be no neighborship. Router ID 5555, clear process. And go to R3 as well. R3. You're done with R3? Again, check this. Show IP OSPF database. Okay, so this is done. So now you can see I have multi-area configuration is done with area 0 and area 2. Now you will see 3 type of LSA in this topology. So all router must have identical database. So if I go for R4, R4 is expecting type 1, type 2 LSA for area 2, and type 3 LSA, which is advertised by the ABR for area 2. Show IP OSPF database. So these are your summary LSA. Okay. Link ID meaning is what? Network number, prefix number. And since it is advertised by, we have 2 ABR here, 222 and 333. So both is advertising these number. So type 1, type 2 and type 3. So number of prefix is equal to
1 second.
number of prefix is equal to number of type 3 LSA.
1 second. At the moment we are on router 4 and
Yeah.
we are checking the type 3 LSA is receiving the summary LSA from router 2, which has a direct interface. Why is it receiving the advertisement
12.0 is not the member of area 2.
No, it's not a member. I'm saying it's receiving the summary LSA from router 2. And it's being advertised by router 2, the 2.2.2.2.
Yeah, AVR.
Yes, but why is it receiving the advertisement from 3.3.3.3?
So that is also AVR.
Yeah.
How many
Okay,
AVR
within
you
its
have?
Router 3 is also in area 0.
So see, router 2 is also AVR, router 3 is also AVR.
Yeah, I understand why it's receiving from router 2, but I didn't get why it's receiving the summary.
All the
from router
AVR,
3.
see the router 3 is also connecting area 2.
Yeah. Okay.
Router 3 is also connecting to area 2.
Okay.
Router 2 is also connecting to area 2. So for router 4 perspective, you have now 2 AVR.
Okay.
So if I go for R4, and here I will use the command show IP ospf border router.
It just should have 2 of them. Okay.
These are your 2 AVR, 222 and 333. Okay, AVR, AVR. So both is advertising. This is what advertising router is, router ID of the AVR. So type 3 LSA advertised by the AVR, and that is exchanging the inter area information, the route which is belongs to area 0 in this example. Continue with next, the link between 1 and 7. So this is the member of area 1. So go to R1. I will go to interface, which is gig 00, and we'll say IP ospf 1 area 1. Go to router number 7. Now in router number 7, because this is the stub router and there is no other area connected with this one, so I will go to R7. And another way to advertising network information, I will say here router ospf 1. I know that all the link is the, or more specifically I can say first to octet is the must match, and third and fourth could be anything. This is the member of area 1. So now all this link is participating. The link which is connected with R7 is now also the member of area 1, and this is we can confirm with the help of command show IP ospf interface brief. So these are the link which is participating in ospf. Okay, these are the link participating in ospf. So now if you go for, if you look this topology, for router 4 perspective, router 4 want to know this update, or in other words, router 1 want to know all these routing update. Who will be the AVR for R4? How the router 4 will learn these routing information? It is through the AVR, right?
Yeah.
And who is the AVR for R4? They are 2 and 3. So 2 and 3 is now also advertising. So in this example, router 1 advertising this link information to 2 and 3, and 2 and 3 passing this information to next area.
Yeah.
So if I go for router number 2 first, or 3 first, and using the command show IP ospf database, so I will see 3 type of LSA, type 1, type 2 and type 3, which is advertised by the AVR. Now here how many AVR I have? 3 AVR. Router 1 is also the AVR now.
Yeah.
Router 2 is itself is the AVR. Router 3
So
is itself is AVR. So this router 1 is advertising this link information. Router 1 is advertising this prefix information. So all this prefix is advertised by the R1. So router link state of area 2. Since it is a AVR, it is making independent LSA for all the area. If you go for R4, you will see 3 LSA here. Show IP Ospf database. Okay, type 1, type 2 and type 3. But you can see these number. Originally these number is belongs to area 1, right?
yeah.
But here it is, this router is receiving from their own AVR because the view is only up to the AVR for one area. If you're using the command show IP Ospf border router here, so you still have view up to its own AVR. If I go to router number 2 or 3, and from here it will see three border router. Show IP Ospf border router 1 2 3. So it has a view up to 3 AVR. Area 0. This is belongs to area 2 2222 via this 35.5. Okay, so now I can see type 1, type 2, type 3 LSA, but here I want to see the type 4 LSA.
Yeah.
Type 4 is only possible if you're going to be redistribute external routing update. In these examples, router 6 is the participating in ERGRP domain. So that means 4 and 5 is now, they will be act as a ASVR. So go to 4 and here you have the IP address is 44. So go to 4 first and look for show IP interface brief, and I need to be run here.
Just to be clear, router 1 is not as an ASVR.
Router
Router 1.
is also acting as a ASVR, correct? Yes, any link which is going to the external domain,
because
that
of
router
its
is becoming the
connectivity.
ASVR in
Because
Ospf.
of its connectivity to the ISP.
ISP.
Yeah.
Yes. But right now see the router 1 is not act as a ASVR, although it is connected, but you're not originating any default route. So far you're not receiving any type 4 LSA from there.
Yeah.
So over here, before to go for that thing, so you can see here you have only, you are in R1 and show IP, show IP Ospf database. You have only type 1, type 2 and type 3 LSA. But here router 1 can ping 88888, sorry, because it knows, sorry, I need to be done on block ping, it is ping 88888. It knows how to reach ISP network. But if I go to router number 2, or let's say 7 have no idea about this network. Reason being, what is the reason for this? If I go for R3 as well, show what happens with this? Me log out for a minute. Okay, so free, yeah, so log out, close, something is happening with internet. Okay. Okay. So go to router 1 and here if I go to router number 2, router 2 do not know default route information.
Yeah.
Show IP route. So router 2 have no information about default route. This is because router 1 is not originating any default route.
Yeah.
So I will go for router Ospf 1 and I will say default information originate. Default information originate. This is conditional advertisement, meaning if I do not have a default route in the local table, there is no default route will be advertised. But there is also one more keyword which is known as always. Always meaning unconditional. Regardless of default route is available or not, it is always will send default route to all other members, which is not a recommended approach.
Yeah.
So originate because I have a default route. So now if I go to router number 2, now I will see type 5 LSA here.
Wait, before you go, so it means if you have,
So-
let's say, 2 default routes to the same router, in that case, then you could set which of the default routes you want to originate.
If you have,
2 external networks connected, or 2 default routes.
you can do this. You can do this by see. Best practice is advertise from the both router, but tune their metric.
Okay.
Because by default there is with the better metric that will be going to the routing table. So route traffic will go to that best gateway. So advertise from the both router, but set which one is your primary, which one is your secondary. So the secondary router increase the cost.
Oh, okay.
Default cost is 1.
We have a router like that. It's connected to 2 external vendors,
Uh-huh.
2 ISPs.
Uh-huh.
Yes. That's
So in this
what-
case you can say like this, by default cost is originate with 1. If I look for router 2, show IP OSPF route, show IP route only. If I see show IP route, I can see there is a default route with the metric is 1. So default cost is 1. If I go back to here and once again using the same command router OSPF1 default information originate, but if I set metric is 2, so default is 1, now you setting metric is 2, that means router 2 is now getting metric is 2. So this way you can make primary and secondary approach. And now you can see because router 1 is now becoming ASPR. That means now you will see 2 more type of LSA, type 4 and type 5. Type 4 meaning over here. You will not see type 4 in R1 because R1 is itself originating.
Yes.
You will see type 4 in R4, which is telling who is the ASVR, in this case router ID of the R1. If I go to R1 and we'll see show IP OSPF database, I will see type 5 LSA here, type 1, type 2, type 3, and there will be a type 5 LSA.
Yeah.
which is advertised by the ASVR. And if I see now from router 2 perspective, or if I go to R4, in R4 you will see type 4 also, which is your summary ASVR summary LSA. Type 1, type 2, type 3 advertised by the AVR, type 4 summary ASVR, and this is also advertised by the AVR. So AVR is advertising about the ASVR information, who is the ASVR. And then there is a type 5. So advertising router is, so all these LSA is now available, but still router 4 cannot ping 888. Do you know why? Because there is no NAT is configured.
Okay.
Because there is no NAT is configured. So simply here for the quick, I will say access list 100 permit IP match first to octet, third and fourth could be anything, destination is any IP NAT inside source list number 100, interface going to the ISP gig 1 /1 overload. This is my IP NAT outside network, this is my IP NAT outside, and rest of the link 2 and 3 and 0 230. It is consuming, NAT is consumed sometimes a lot of space, CPU. Trace back. So it will take some time to, so in the meantime we'll continue with here. So this link is the member of EIGRP on R4.
Yeah.
So show IP interface brief and start EIGRP process, which is EIGRP1. I'm running over there, and then the network number is 172.16.46.4 with exact wildcard. So now it is going to discover EIGRP neighborship. Similarly, go to 5, start EIGRP process, router EIGRP1, note summary is not required here, this 172.16.56.5 with exact wildcard. So now I have the EIGRP neighborship. I will take this EIGRP route and announce in Ospf. So router Ospf 1 redistribute. So redistribution we'll discuss later on, right? But here right now redistribute EIGRP 1 and use the command subnets. Go to the EIGRP vice versa redistribution EIGRP process and redistribute Ospf 1, and this also need metric, all the 5 attributes, which is here I'm simply saying all 5. These 5 attribute is the minimum requirement, which is generating seed metric. I will discuss this seed metric concept later on. So right now, just to see all type of LSA in Ospf, I'm including this EIGRP domain also. Go to R4, Same thing over here. Router ospf1, redistribute EIGRP1, and in the latest code this subnet command is also not required, but best practice is even if you use, there is no problem. Router EIGRP1 set composite metric. So EIGRP is using 5 attribute: bandwidth, delay, load, reliability, and redistribute ospf1. So now there is a vice versa redistribution. So that means if I go to, let me check what is happening with R1. So it's done with processing. All the internal link here, which is gig 00 IP NAT inside gig 0/2 IP NAT inside, and gig 0/3 IP NAT inside. Okay, so NAT is done. That means in this topology all these routers should be able to access internet. So if I go to router number 6, this is configured with EIGRP. It is expecting Ospf update as an external update. So show IP route here. I'm receiving all these external update, including default route also. Okay, there is here. That means I can ping 172.16.70.7. This is the look back on R7, and I can also ping to ISP, which is 8.8.8.8. Okay, so you have reachability.
Yes.
So in these examples we have done with basic configuration. Ospf basic is done. So all the router, if I go for R7,
Can we check if we can, how the EIGRP is advertised in the route 1?
how EIGRP? Yes, in R7 you can see on R7. So all the router within the Ospf domain is receiving type 5 LSA. So in router 7, show IP Ospf database. You can see there is, this is the ASBR, which is advertising the ISP route.
Yes.
This one is your also ASBR advertising EIGRP route.
Yeah.
EIGRP route. So if you see the routing table, by default Ospf is originating external route with the metric type 1, with metric type 2,
Okay, that's
E2 with metric type 2, and with the seed metric is 20. Default behavior. This is Ospf, this is external, this is type 2, and that one is your seed metric. You can see internal interface is not doing the additional addition of their interface cost.
Yes.
So 20 originate by the ASBR and it is remain 20. Difference for the default route, seed metric is 1, because this is you have tune which is 2, but default route seed metric is 1. Other than the default route, seed metric is 20. So any questions in the basic?
So far, remember in the beginning we set the
Assume this. So show IP route. Look for the route number 12.0. It is taking free. Metric is free.
Yeah.
via, it is doing the load balancing here. So let me disable the load balance. I will say I want to prefer the path through this link. So I will say gig 0/1. I will set IP ospf coast is, let's say, 10. Show IP ospf route. Now there will be only one best path, which is 25.3. okay, the total metric is now 3. So if I go to, so the next hop is 35.5.
Yeah.
And if I go to router number 3 now, where is 3? This is the 3, and from 3 to reach show IP to route, from 3 to reach 12.0, it is again doing the load balancing with the metric is 2. So let me again, I will say interface, I'm going to be increase the cost of this link gig/2, interface gig/2, IP ospf cost is once again 10, and show IP route. So it will say, in order to reach, my cost is total metric is 2, right?
Yeah.
And show IP ospf interface brief, and on this link my cost is 1. Okay, so 1 plus 1 plus, what is the cost of this interface?
Supposed to be 2.
So go to R1 and show IP interface brief gig free. Which one is gig free? Okay, gig free. So we are looking for a wrong interface.
Yeah.
So gig 3 with configured with cost number 2. So in this case gig 2 is configured with 1. So 1 plus 1, it is 2.
Yeah.
If I go back to R5, and from here you can see the total metric is, to reach 12.0 is 3. So 1 plus 1 plus 1.
Yeah.
If I go to this interface gig 00 and set cost is 2, so 2 plus 1 plus 1, it will be 4. Interface gig 00 and IP ospf cost 2, because now my link cost is 2, member link cost is 1 to reach, next member cost is 1. So 2 plus 1 plus 1, total metric to reach 12.0 is 4.
Yeah.
To reach is 4. So it is only concerned with outgoing interface value.
Yeah.
So we have done with the basic. Let's take a short break. I'm going to be pause this video between router 1 and router 2 link. It is once again on per interface basis. In OSPF you can configure area wise authentication. Area wise meaning it is forcing that all the link which is the member of one area, you must participate in
Yeah.
authentication flag.
Okay. Yeah. ARGRP was
only per interface base.
Okay.
Here, so what I will do, I will set in router 1 area wise authentication. That means all the link which is the member of area 0 must match that flag. How to do this? How to? I will go to R1, and for router 1 perspective I can see here show IP ospf neighbor. These are the neighbor I have 2 3, and this one is the 7, which is, I will set router ID. Router ID, it is 7.7.7. Clear IP ospf process, and then say yes. Go back to R1. So router 1 area wise authentication, show IP ospf neighbor. The moment I enable that flag, you will see that these two neighbor will be removed, because if authentication is not matched in all the neighbor, there will be no neighborship. I will set a router area wise authentication, go under the OSPF process, and will say area 0 authentication. Now if I'm not using an extra keyword, so then it is a plain text, which is not recommended. So I want to set message digest. So this is setting the method, not setting the key. Key again you have to be specified on per interface basis. But the moment I will set this key, this method, so this meaning that all the link which is the member of area 0, it will say there is no valid authentication key is available on gig 2. So what will be the result here? Show IP ospf neighbor, show IP. There is also one more command, show IP ospf neighbor and detail. Very useful command. So this is only showing the information of R7, and here I will use the command show IP ospf interface. So I have these interfaces gig 3, and on this gig 3 I can see here cryptographic authentication is enabled, but there is no key configuration, and it is using the default key ID 0. So key configuration meaning there is no password or key ID set. The result is there is no neighborship. So then I have to go to these interfaces, do show IP interface, do show IP ospf interface brief on this link gig 3 and gig 2. Now I need to be set key here. Interface range 2-3. Okay, I will set IP ospf message digest key ID, and it is asking MD5. Now what is the key? Let's say it is Cisco. Similarly, go to 2 and 3. So this link is the member of area 0, this link is the member of area 0, but here I will use the per interface authentication. I will go to this link and this link, because now both links should match that flag. So R1 router number 2 gig 00. router number 2 gig 00. You can see it is receiving the message because debugging is on. So there is also mismatch authentication type. So it is continuously receiving this. We use default type, other one mismatch with the type 2. Type 2 meaning MD5 authentication. So type 0 meaning default null authentication, 0, 1 and 2. So let me turn off this on all. Debug is on. Gig 00. Go to gig 00 and say IP ospf authentication. First command it will say enable the method. Second command IP ospf message digest key ID must match. This is MD5 and password is Cisco. Once you will see configuring this command, you will see the neighborship is up. Loading is full. Same thing we can do on R3 on gig 00 interface. There is no neighborship. Interface gig 00. First command, this is going to be set authentication method, which is I'm using message digest, and IP ospf message digest key ID must match. This is MD5 hash, and then the password is Cisco. Make sure you're not using any space because space is also password. So then I can see again neighborship is up. So if I go back to R1 will once again will see 3 neighbor. Show IP ospf neighbor, and here I want to see the detail also. So neighborship with 333. Okay, the useful command here is this will show you uptime for this neighbor. At what time this neighbor is discovered. So if there is link is resetting and you want to check that last reset time, you can say this by using this command neighbor uptime. Here this is not showing the authentication is enabled, but there is also one more command, show IP ospf. I want to see for router. This command is also telling you that how many time is SPF is running. If you want to confirm, then you can use this command show IP ospf, and this will show you the number of time the SPF algorithm is run by this router. Here this one, SPF algorithm is executed by this router. Recording is on. Recording is on. SPF algorithm is executed 28 times, right? And here you can also see the reference bandwidth. Reference bandwidth default is 100 MB. Here you can also see area has message digest authentication is enabled for this backbone area 0. Number of interface in this area is 2. Yeah. So then you have area 1, but on area 1 there is no area wise authentication is configured. So area has no authentication. So next we have after authentication summarization. So if you look for
similarly what we have done now, we have just use same approach to implement
on all other members.
All other, okay.
Same approach we can.
The network wise from the router 1, you specify the interface range G1, G2. Gate to gate 3.
Yeah,
Yeah, and that did the authentication from router 1 to router 2 and router 1 to router 3.
correct.
But at the moment router 2 to router 3, within that area, we don't have the authentication.
Yeah, so there is on that link, because on router 2 I'm using on per interface basis. I'm not enabling area wise authentication. In router 1 I'm enabling area wise authentication. So this is forcing you that all the link which is the member of area 0, you must set password.
But then
Forcefully forcing.
But then that's only going to affect those which router 1 has a direct link to.
Correct. Only it is going to be correct which is directly connected with R1
Okay.
in that area 0.
Okay.
Next one, after the authentication you have summarization. So for summarization meaning combining many network into one. In Ospf we can do summarization only on AVR and ASVR. So here in these examples, if you see router 2 is receiving type 3 LSA from router 1 regarding area 1 network. So go to router number 2 and this is visible with the type code OIA in the routing table. Show IP route is the command and you will see the type code OIA for this. So let us assume that I want to summarize these 4 network. This is advertised by the AVR, and in this example for AVR is router 1 for these network 70, 71, 72, 73. So what will be the summary address if I want to combine these 4 network? So if I want to combine these 4 network, so what will be the summary address for these 4 network? Summary address with subnet mask. So simple formula. Let me know if you can find out summary address. 70, 71, 72, 73. Take the least number and then highest number, convert into binary. Look for make the division between number of ones and number of 0. Make the addition of number of ones with the earlier interval. In this case earlier interval is /16. So /16 plus number of ones will give you the slash value. Based on the slash value you can find out block size, subnet mask. This is what I need here, and then net ID also.
Yeah. Is that right? So 70 will be here.
So take the smallest number, which is 70, and then the highest number. Convert into binary by using the 8 block size, and then make the demarcation between ones and 0, and then find out prefix length. Then look for block size. Then look for subnet mask, and also the network ID for this summary address. Resume this. Go to AVR and go under the Ospf process, router Ospf 1, and because these root is belongs to area, thank you, this root is belongs to area 1 in the first place, right? So area 1 range, and then summary address, which is 172.16.64.0, their subnet mask. In this case 240.0. This will be subnet mask. Done. So now, because this router is doing summarization, it is pointing the summary address with their null interface in order to avoid looping. Show IP route, it will generate summary address here with the value, this one, so 64.0 pointing to null 0. So this router is now advertising this number to upstream router. So if you see router number 2 here, earlier I was able to see these 4 network. Now I will see only one, which is 64, and also other network is available. But why? Okay, these are coming as a type 2 also. Now this network is also available as a type of external network. 71, 72, 73. Why this is happening? .4 24.4. 24 direction is 24.4. It is from that side. 24.4. Where is that?
Does it have to do with the cost you put in so that it determines which route is getting the information from?
Come again?
As in,
As
router 2 receiving this information from router 4, rather. I mean, from the 240. Does it have to do with the link cost, the link metric which you put in?
No.
Because
Here, see, this network is belongs to
router 1.
this network is belongs to R7.
Yes.
70, 71, 72, 73. And now you're doing the summarization there.
The summarization we should ordinarily receive from 12.0.
And here you're doing the redistribution on 4 and 5. Okay, 4 and 5. So what is happening in 4? Show IP route 70, 71. This is via 45.5. Okay, and 45.5 is connecting to R5.
So we're receiving from 35.3.
And go to R5 here. R5 show IP route. These are your external. R5 is getting from external 70, 72, 73, 74 via 56.6. Okay, and 70 via 56.6, and go to R6. In outer 6 you don't have these number. Show IP interface brief and show IP route. That means you have these number. There is 70, 71, 72 from 40.4. This is the loop condition somewhere else. 46.4. Okay, so it is getting from 46.4,
R4.
and router 1 is doing summarization for area 1 network. Okay, so because root number is, this is what problem is, why this is happening. 172.16.64.0. okay, and within this your slash value is 20.
Yeah.
The range for this network is, first number is 64.1,
The last number is
so the next network will be
79.25.
80, right?
Yeah.
This will be your next network.
So the last number
So the last number will be
79.255.
254. Now because under this number is also included, 46, 56, under this summary root. So that is also summarized, and this is creating problem here. For simplicity, what I will do here, I will change the first octet here to 192, because in this in this case this problem will be happens. What is happening here? Because the root member is available within this network range, and that is also summarized. This is where problem is having. So what I will do, I will change this number first octet with 192, and we'll see the result, what will happen. So go to R7. Do show IP interface brief. Interface loopback 0. IP address 2.168.70.7. And 72. Go to R1, go to Ospf configuration and remove that command to show run section router Ospf, and here I will remove this command area 1 range. To show IP route. So I'm now getting where is those number? 70, 71, 72, 73. Show IP route. Clear IP Ospf neighbor. Process. Go back to R7 and see what I did there. Show IP interface brief. First octet is change. Show IP Ospf interface brief. And these are not member because show run section router Ospf 192 network is not advertised. So go to router Ospf 1 network 192.168.0.0 and area 1. Then go to R1, show IP route. Still I'm getting these number from where? 71, 72, 73.
Do you have to clear the OSPF process between on 17.0?
Between?
17.0 between router 1 and router 7.
I did. I have these 70, 71, 72, 73. Okay. And from router 5 is advertising these. Router 5. Who is router 5? R5. R5, go to this R5. R5 is getting from the external, so let me clear IP ospf, clear EIGRP neighbor. Membership is cleared.
We have to clear the OSP.
Okay, enter area route. Enter area route. Okay. This earlier, why that problem was happening? So now it is 70, which is fine. Remember, there is I will discuss this in redistribution section. I will redesign the same network when we go for redistribution. Routing redistribution is always occurred from what is available in the routing table. What is available in the routing table? If route is learned via EIGRP, not via the OSPF. So when I redistributing from EIGRP to OSPF, because route is learned by the EIGRP, it is going to redistribute now from OSPF. That was a route feedback problems. This is looping conditions. I will simulate same scenario when we go for redistribution section. But here,
so in this case, we had R4 learning from R5, R5 learning from R6, R6 learning from R4, and
yeah. So then, yeah. So this is what the loop. That was the loop was happening because of the routing is redistribution is occur from the routing table, and based on the longest match, because I suppress route. So based on the longest match, it is only learning the longest prefixes, and then redistributing back into the. So here, once again, for router 2 perspective, now it will see the correct output here. Show IP route. So I can see now these 70, 70, and then I will go for R1 and doing the summarization of this area 1 route under OSPF1. We'll say area 1 range command, and this time 192.168.64.0. Subnet mask is 240.0. Then go to router number 2, use the command show IP route, and now I can see only this number. So that is the summarized format, but still I can ping 192.168.70.7, 71.7 and 72.7. There is also 73.7. Summarization on ABR. So remember, we can only do summarization on a specific location in Ospf, which is ABR and ASBR. ABR is summarizing area route, and ASBR summarizing external routing update. So next we have, after this, next is stub area.
Assuming we should face a similar problem due to similar IP blocks where one falls within the range. Like the first time you did a summary, even though you specified area 1 summary, I was showing in the EIGLP block. So that one was also redistributed into the OSPF. So assuming we should have a similar problem, is the best resolution to change our IP?
You have to implement there is a solution for this. You have to implement route tag, so routing feedback. So if route learns from the one domain, do not redistribute in the second domain.
Okay.
So in that case, you have to avoid that route feedback problems.
Okay.
So I will simulate. This is the metric based loop. That was the metric based loop. So I will simulate same scenario when we go for redistribution cases. So next one we have, next example, we'll configure a special area. So in this case we can see that area 1, this router is not connected with any other external network. So I can configure this area with totally stubby, right? So totally stubby meaning it is only going to be allowed type 1, type 2 and type 3 in the form of default route. So go for this. So far if you go for R7, you will see here in the routing table so many route. So consuming routing table space, show IP route. So I have type 5 and type 3 LSA available, right? What I will do, I will go to the OSPF configuration, router OSPF 1, area 1, and I will say stub. Now stub flag must match with all the members which is participating in area 1. Otherwise there will be no neighborship. You can see it is going to be declare all this neighborship in down state. So show IP OSPF neighbor, I don't have any neighbor. It is in down state. It was full to down. Show IP route, it only knows directly connected route. Go for router 1. Under the process router OSPF 1. Now since router 1 is the ABR and ABR is advertising type 3 LSA, so on this router I will say do not advertise type 3 LSA and making that area is totally stubby. How? Area 1 stub, then I need a command no summary. This command is only required on the ABR because ABR is the router which is exchanging type 3 LSA. But here I am saying do not send. Same commands I need to be applied on next ABR, which is router number 3. So go to R3, router OSPF 1 and area 1 stub, no summary. The result is that if you go for R7, you will see only 3 LSA, type 1, type 2 and type 3 in the form of default route. Show IP Ospf database. You have type 1, type 2 and type 3, which is summary LSA in the form of default route only. So advertised by the, I'm expecting also the second AVR here, which is so far it is okay, it is 1 only because it is 7 is connected with 1 only, 1 neighbor. Yeah, this is fine. In the routing table you will see the real advantage. You will only see the default route to go to the external network from this area. That means if I ping 88888, I can access internet. Okay, if I ping 888 but my source address is loopback 0, what are you expecting? Is it reachable or not?
Should be reachable.
In this case it is not reachable because NAT is not happening for 192.168 network. NAT is only happening for 172 network. Show run section IP NAT. This will say this is doing natting for list number 100, where list number 100 says I only permit this network number. That means if I go to R7 and ping this, there is no connectivity because traffic sourcing from this network is not translated by the NAT. What I will do, I will go to my NAT router and simply say access list number 100 permit IP number also allow this network, so that you can also translate this number, destination is any, and now you should expecting the reachability to internet where it is also translated. So if you're not creating any access list, there is no NAT translations, and rule is only valid for dynamic type of NAT, dynamic NAT, dynamic PAT. For static NAT, no ACL is required because static NAT meaning 1-to-1 mapping. Static NAT is bidirectional NAT. Next, so you can see we can also ping the ISP. We should able to ping 60.6, which is the loopback interface. 6.6. Let me check. It is 6.6. It is 6.6. 6.6. If I do the trace route for this network by disabling the domain lookup, so that it can no IP domain lookup, and then say trace to this 172.16.6.6. We'll see the traffic is going from 1 to 2, 1 to 2, 2 to 4, and 4 to 6.
So it means in a step network like this,
Yeah.
area 1.
Uh-huh.
If I want to see, looking at the neighbors, I wouldn't be able to fully tell what they call it. That's just to save the routing overhead. I'll be able to fully tell who it's connected to. Or
Router
who
1?
Router 7, or who anyone in area 1 has connectivity to from the IP routes, from the show IP routes. I wouldn't, because I'll only get T1 and T2 information, and then the default routes.
Yes. So in this case, you have the limited view only.
Yeah. So assuming I want to know who, let's say anyone in area 1, let's say router 7, router 1, or any of the loopback, have full access to, I'll have to do the ping test.
Yeah, this is only possible with ping test because now we have only default route in this router.
Oh, okay. or I'll have to check and find out the properties of the area. If it's stable, then I know it has more connections than what is showing me here.
What you want to check? What?
I mean, let's say I check the area summary and I see the properties that it is totally stable or not so stable.
Okay.
That's when I know that there will be more connections or more links than what I was seeing in the IP logs.
Yeah. So this is what is happening. You have many other network is available, but router 7 perspective now it has only viewed to only default route.
Yeah.
But from here there is no way to check show IP Ospf border router. This will only give the information about who is the AVR, because view is only up to the AVR. It has no view up beyond the AVR. Next one, so the totally stub is done. Next case, in this examples we can see that area 2 is connected with external network. So in area 2, what you want to minimize flooding of type 5 LSA. So you can configure area 2 with not so stubby area here. You cannot configure with stubby area, otherwise what will happen? EIGRP route will not be accepted. So if I go to here R4,
Can you repeat that? We can't configure totally stable area in area 2.
otherwise the EIGRP route will not be accepted
Okay.
in your OSPF domain, because type 5 LSA is not allowed. Only type 1, 2 and 3 in the form of default route.
Okay.
If you go for R4,
So assuming the ISP was rather the 6.6 or like beyond the 6.6, and then the EIGRP was rather beyond the router 8, then it will mean that in the area 1, they would rather have the not so stable area, and then maybe the EI, what would have now become,
yeah.
I said, assuming that the ISP was rather at this end, and then
Okay, router 6 is ISP, let us say. Okay.
and then the EIGRP was rather beyond this
Okay.
end, then it would have meant that this could rather have become the NSS.
No, see this the same case is here. A router 8 is ISP.
No, I'm saying assuming that this is not the ISP, but rather the ISP is at this end, and then the EIGRP network is beyond this end.
Okay.
Then what to do that was this area. Then what to do that meant is this could have been the NSSE.
No. For this rule is not changed. This is my totally stubby only. If this router is connected with, then it cannot be become the totally stubby.
No, not this one. If this.
Yeah. So this is where router 1 is connected with router 8.
And
This is the external network.
EIGRP.
I am still configuring this with totally stubby.
Okay. Well,
I have configured this with totally stubby and it is accepted. Communication is happening. The problem is not here. Problem is your edge router is connected with
ISP.
external domain. Yes, whether it is a ISP or whether it is an external company. In this case, this is the edge router for area 1.
Okay.
This one is the AVR.
Yes.
So if this is connected with external network, then I cannot configure this area with totally stubby or stubby flag. Otherwise, type 5 LSA will not be allowed.
Okay.
So in this case, if let's say link is going to ISP side, this is the ISP here. So I can still configure this area with totally stubby. Now then I cannot configure with this totally stubby because this is the edge router.
Yeah.
But if this router, this is my AVR router, which is connecting with backbone area.
Yeah.
So the same rule apply over here. Router 1 is the AVR,
Yes. And also that is.
also connected with external network.
Yes.
But this area 1
Yes.
is not connected with, this router is not connected with external network.
So we can still use it as a totally stable.
Yeah.
Understand.
So this is I have configured with totally stubby. But in this case, you cannot configure area 2 with totally stubby. Otherwise, result will be
EIGRP.
No.
EIGRP route is not exchanged in OSPF.
Okay. Okay.
You getting this point?
So, but then we would have had the default routes. So would you have been able to do?
Yeah. So you have a default route. So see, in when we configure the not so stubby, there is what you have normal, and you have also totally not so stubby area.
Yeah.
In totally not so stubby area, you have type 1, type 2, type 7, and there is also the default route which is advertised by the area.
Yeah.
So with this logic, with this default route logic, this router can also access any other route.
Okay.
Okay? You getting this point how this topology is going on, or this Ospf is working here?
Yeah.
You was asking earlier, this router is over here. Let us assume that router 6 is ISP
Yes.
and this is EIGRP.
Yes.
You're saying then I cannot configure
I was asking.
area 1
would
was
this have
as a
been
not so stubby area.
NSSA rather than a totally stubby.
Yeah, so this the rule
I think
same
another
design we have over here.
against another scenario I presented that this place cannot be
Totally stubby.
totally standard.
It would rather have been NSSA.
Yeah, so if this router is connected with EIGRP domain.
No, not this one. Not this one.
Okay.
This area 1 to 8, like the way this. If this was an EIGRP domain,
Okay.
yes, then this one could not be totally stubby. It would have
Because-
had to be NSSA.
Because if this side is EIGRP, this place because we have to exchange the OSPF and the
But we are still communicating with ISP network.
Yeah, through the default.
Under that
route.
scenario, then the ISP will be at the side.
In this scenario, this would have been the EIGRP network, not ISP. So then wouldn't have used default routes.
Yeah.
Yes. So then this will not be totally stubby. It would have rather been NSSA.
So then you're going to be configure.
So that
okay.
OSPF
Let me
EIGRP
configure
routes
this is
can
with
be exchanged.
EIGRP. Let me configure this is with EIGRP.
Yes.
And you want to know that can I ping this network or not?
Then the ISP would have been here.
This is let us assume that is the ISP. So ISP meaning external network.
Yes.
So your question is then I cannot ping from 7 to 6.
No. What I'm saying is that
We cannot declare this site to be totally stubby.
so then we would have rather had to set this one as NSSA and this one and this area rather as totally stubby.
See, if this router is connected with external company, this area is connected with external company or external ISP, then
It cannot be totally stubby.
it cannot be totally stubby.
Yes. So that's what I was asking.
Yeah, it cannot be totally stubby.
Yeah.
Yeah.
Okay.
Do you get me the question that if this was the ISP?
Okay, this is ISP.
Yes. So then this would have been the edge routers. And
Correct.
that we're providing default routes.
Correct. Sure.
Would this have been able to be configured as totally stubby?
No.
Okay. So
No.
then this will also be NSSA if you want.
You can configure that as an NSSA.
Okay.
Okay.
Yeah. I get it. This is interesting.
Yeah, sure.
So I'll go with router 4. Router 4 is the member of area 2 and router 4 is also connecting EIGRP domain. That means if I say router OSPF 1, if I say area number 2 stub, it will say OSPF 4 is ASBR without valid area and it is going to be shut down, and result what will happens here. So let me complete this configuration 4 and also configuring 5 with stubby area, right? Only stubby config, not so stubby so far. Area 2 and stub. It will say adjacency for 444 ASPR without valid area. Router is currently an ASPR while having only one area, which is in stub area. Go to your 2 and 3, which is also the member of area 2. So far, if I go for 4 and we'll see show IP route, I'm still learning the EIGRP route, but so far I don't have any OSPF route. Reason being, neighborship is removed. Show IP EIGRP topology. I have the EIGRP routes. Go to router number 2 and configure this router with area 2 stub. You will see the neighborship will up. Also configure router number 3 with area router OSPF1 area 2 stub. You cannot configure area 0 with stub flag, so only the other area you can configure with stub flag other than the area 0. Neighborship is done. Now if I go for R4 and we'll see here show IP route, I have the EIGRP route and OSPF route. Show IP OSPF database. In this router I do not have type 5 LSA. External route is not there. There is no type 5 LSA because the area is configured with stub, and in stub type 5 LSA is not allowed. That means if you go for router number 2 or here router number 2, you will not see any EIGRP route here. So there is no EIGRP route. That means you cannot ping 172.16.6.6. No reachability.
So that's how it now becomes an island.
That is island, right? Isolated
from
network. So what the idea is that I want to minimize type 5 flooding in area 2. So I want to receive external LSA from the one side but not from the other side in the OSPF domain. Then you're configuring that network with type 7 or not so stubby area. So go for 4. Router OSPF1 and remove this command no area 2 stub. Then say area 2 not so stubby area. Go to 5. Router OSPF1 no area 2 stub, and then area 2 not so stubby area. Now since this is configured with not so stubby area, but right now neighborship is not there, so let me complete configuration. So go to 2, router OSPF1 and say remove that area 2 stub, then say area 2 not so stubby area. And if you want to configure totally an SSA so that you can also minimize more overhead by suppressing type 3 LSA, then say no summary, because this is the AVR which is advertising type 3 LSA. Go for 3 also. The router ospf ospf 1 no area 2 stub area 2 NSSA no summary suppressing of type 3 LSA. The result is now in router 4 and 5 you will not see type 5 LSA now. But instead of type 5 it is converted into type 7. So type 1, type 2, type 3 in the form of default route which is advertised by the ABR, and then you will see type 7 because the area is configured. So type 1 router LSA, type 2 advertised by the DR network LSA, type 3 summary LSA advertised by the ABR, and then you have a type 7 which is converting your earlier was 5. So these are your external EIGRP update. If you look for the routing table for R4, you will see only default route advertised by the ABR in R4, and from here you still have reachability to your ISP network with the help of default route logic. Then if you look for the R5, same status on R5, show IP route. So you have default route advertised by the ABR, and you have still reachability to your ISP network 888. If you go for router number 2, this is the ABR. So it will see type 7 and then will do the translation to type 5. Show IP OSPF database. So you will see the type 5 and type, this is the type 7. So now this router is also becoming not so stubby, sorry, ASBR. This is also becoming the ASBR, and you have also type 5 for this network. And you can see here, even though I have also router 2, but who is doing the translation? Only router 3 is doing translation.
So that's why you know, okay.
Because of more than 2 AVR, only one of them will do the translation, which is using the highest router ID. So 3.3.3. When you are using the not so stubby area, it is also generating one more address which is known as forward address. Because now forward address meaning this router is also ASBR, this is also ASBR, because it is configured with not so stubby area. This one is configured with not so stubby area. But if you look for router 1, for router 1 perspective, who is the real ASBR? 4 and 5. Because now type 4 is not available here. So in order to tell to other area that the real ASBR is not actually these 2 and 3, but it is 4 and 5. This is where the forward address will help or generated in not so stubby area. So forward address is the any IP which is connected with 4 and 5. So here
this will be forwarded by
both ASBR, both real ASBR. So if I go for router number 2, show IP protocol here. So this is giving the information that it is an area border router and autonomous system boundary router also. If I go to R1, in R1 perspective, it will only see type 5 LSA, show IP OSPF database. It will not see the type 7 because type 7 is only remain in not so stubby area. So you have type 5 LSA for this network,
Okay. So
which
the
is
first-
advertised by the translation is done by the AVR, which is using the highest router ID. And if I see the show IP OSPF database external, and here I will see the forward address also for the network number. See, the forward address is not generated by this default route because that is my ISP route. So 111 is advertising ISP default route, but here you can see the forward address on forward address is this 45.5, any IP address which is connected with router 5, and .5, 45.5, this one 45.5.
How many networks?
Highest
IP.
IP address of that network,
45.4,
of that,
45.5. Okay.
yes. So show IP route, I still have a route number to reach this destination. I still can see this network 46 and 56, and this one 6.6. I still can ping here 172.16.6.6. If I go to R7, for R7 perspective, it has only view of the default route. Show, because this one is a totally stubby. Only it has a default route, but it still can ping 172.16.6.6. So one-way translation.
So
Why?
in this case, because R1 sees the external network through R2
Correct.
because of the NSSA.
Correct.
So R2 is being assumed to be
Forwarding.
an ASBR.
R2
Is then assumed to be an ASBR.
R2 will be assumed as ASVR if I see so this output will be on R1, what you want to see.
Is that? I'm saying, so now if you check on R2, R2 be recognized as an ASBR.
Correct, both router 2 and router 3.
Okay, both R2 and R2. Okay.
So this is we can see with the help of command show IP protocol.
Okay. So without the NSSA configuration, R2 and R3 will just
It's only the
be
AVR.
Okay.
Without NSSA, it is only the AVR. Okay, so this way we can configure special area. And now we have network type. Network type meaning OSPF also have a capability to change network type according to the requirement. So in this case, to simulate this, what I will do, I will change network type between 1 and 2. Okay, why do I want to change? In order to remove the additional overhead which is generated by the type 2 LSA. So on a point-to-point link, you can configure explicitly the link type is point-to-point rather than broadcast. Otherwise, you will generating also additional overhead for type 2 LSA. So for this, how to do this? You have to be do on per interface basis. Network command show IP interface brief. So I will do this
What's the
on.
difference between do, show, and show?
Yeah, so do meaning I am not in the privilege mode. So then I am using do command.
Okay.
So if I am in the privilege mode, then do will not work here. So do will give the admin right
Okay.
above from the privilege mode. So show here on this link I will change network type. So by default network type here is interface for gig/2. This is network type is broadcast. How to change this? Go to this interface gig0/2 and you have a command IP ospf network, then question mark. These are the different types of network: broadcast, non-broadcast, point to multi-point, and point to point. So here network type is point to point. Go to router 2 also. Show IP interface brief. IP which is configured with this will be on gig 00, and IP ospf network point to point. This is done. So now if I see, so there is no DRBDR election on this network type. There is no DRBDR. Network type is point to point, and there is no DRBDR election on this type of network. So DRBDR only on broadcast multi-access and non-broadcast multi-access. Okay, so next one, virtual link. So for the virtual link perspective, what I will do, I will now see one of the key point regarding virtual link: underlay area cannot be configured with special area. So if virtual link is only possible if area is not configured with stubby flag. Okay. So in these examples, to simulate virtual link, I need to be remove. Totally stubby, and then I'm connecting one more router here. So take more router, one node, take one more node, CPU can set RAM as 4 GB, internet is fine, and I only need one router here, it will be sufficient. Save. And to connect link now, I should shut down first this. Save. Then stop. Then connect a link. And then start these both router. Start and start. So in this example, 1 and 7 is the member of area 1, and let's say 7 and this router is the member of area number 3. So area number 3 is this contiguous area. So area number 3 has no connectivity to rest of the network, and you want to provide connectivity to rest of the network. Solution number 1, connect a link to the backbone area, which is, if I connect a link from this router to AVR, this is going to be solve problem. But if the physical link is not possible, then virtual link. So first I need to go to R1 and need to be remove special flag, otherwise virtual link is not supported. So say no area 1 stub with no summary, and also with this. Also say on router number 2. Router 7. Yes. Oops, it says I need to be log out, log out, log out. this will happen, so then I need to be log out and log in at HTML console. 7. Then under the Ospf process, say no area 1 stop. This will once again will discover neighbor. Neighborship is up. So now I will configure link between this 7 and this router is with new IP address. So go to interface gig 0/1. What is the network number? 17.7. Okay, it is overlapping with it is already there, overlap. So 1671, right? Okay, this is the member of IP ospf1 area number 3. Then go to our new router. This is having the interface gig 00. It is router number 9.
On the 71.0 link. I thought that was the loopback.
Show IP ospf interface brief
Okay.
on. I configured this link is the member of area 3.
Yeah, and not the link to one of the loopbacks.
Router 9. This is the link is going to the router 9. No, because I changed the network number. This is 192.168.
Okay.
For the loopback, it is going to different IP subnet.
Okay.
And here I will set gig 00 IP address 172.16, not 19, yeah, 16.71.9. And then I will say IP ospf1 area number 3 and expecting neighborship between 7 and 9. So I have the neighborship. Show IP ospf neighbor. Show IP route, but it is not learning any route information from the other area. So this is where this is a discontiguous area. Now I need to configure virtual link and virtual link between AVR to AVR. So here I have router 7, it is router number 9, this is the AVR, and this router is connected with backbone area. This one is the AVR. You have to be configure tunnel from here to here, and a virtual link is always connected with area 0. This is always will be the member of area 0. Now remember, if
is the tunnel supposed to be from R7 to R1?
no, between AVR to AVR. The virtual link is between AVR to AVR. So look for who is the AVR for area number 3.
Okay.
And then go to that router and then configure virtual link. Important point regarding here, if area 0 is configured with area wise authentication and later on you decided I have to be configured virtual link, then there will be no neighborship. Virtual link will be established until and unless you specifying the
Let's specify the
authentication on
by Cisco.
R7 as well. So in this case, the same thing is going to be happen. So I will go to R7. I need to know what is the router ID of R1, which is we know 1111. So go to ospf1. Who is my transit area? Transit area is area 1. My virtual link, and then it is asking the router ID of the neighbor, or in other words AVR, next AVR, which is 1.1.1.1. okay, this is go to router 1 and then say area 1 virtual link, router ID of R7 is 777. You can see this message, no valid authentication is available. That means show IP ospf neighbor, there is no virtual link is up so far, because this router is doing the area wise authentication. So that means because area wise authentication is there, I have to be set message digest key number. This is MD5 and password is Cisco. I will go to this R7 area 1 virtual link 11111. Here first I need to be enable the flag, message digest flag, and then need to be set message digest key. Okay, so first I need to be enable the message digest flag, which is authentication, and authentication type is message digest. Then I need to be set key here, which is message digest key, MD5 hash, password is Cisco. So now if key is match, then you can see the virtual link loading is done. So now I'm expecting what neighborship with virtual link, this one. So interface virtual link neighbor is there, done. Show IP ospf virtual link. So this is the virtual link with the router ID 111. So it is making a connection to 111, and by default timer for this one is 10 and 40 seconds. It is also enabling the authentication. A result will be, if I go to router number 9, show IP route, so I will see all these external update, and I can ping ISP 88888, and I can also ping external network of the EIGRP 6.6. But if I go to R7 and we'll say router ospf ospf1 and set area 1 stub, this will complain me the area cannot be configured as a stub, it contains a virtual link. So no stub area or not so stubby area supported with virtual link configuration. But this is the temporary solution. This is not a permanent solution. Permanent solution is you should have most reliable solution is you should have a physical link between all other from the other area to backbone area. But if it is not possible, then this is the solution.
We connected R9
Yeah.
to R7. Initially, you just configured the IP addresses. You haven't done the OSPF.
Yeah, so I have done on the interface level. So if you go for
So
R7,
that's how come it couldn't ping. When we checked the IP routes, it couldn't reach the main network. We could only see up to R7.
you said
Initially, when you did the basic
configuration IP address, yeah.
IP address, then you wanted to show routes. We could only see R7 from the R9.
Yeah, yeah. Only one neighbor was there.
Only one neighbor.
Only one neighbor, yeah.
Yes. So now we have connected a virtual link from between the two areas, R7 and R1.
Yeah.
Do we have to configure OSPF? No.
Because virtual link is always with the member of area 0.
Okay, it's already configured on OSPF. So it means R9 can actually now reach the OSPF network without without having any OSPF link or being in any area. R9.
R9 is in the area.
R9 is the member of area 3.
Okay, so it's already OSPF.
Yeah, this is the area 3.
Okay. And then how come at first when we checked the show IP routes, we could only see R7, only one neighbor?
Yeah, because for 9 perspective, it still has a one neighbor.
We couldn't see the rest of the neighbors. Let's say, like if we use.
No, it will not able to see rest of the neighbors because neighbor meaning directly connected link.
Okay.
Oh, see, for outer 3 perspective, how many neighbor you have?
3.
So you will see only 3 neighbor. You will not see that the connectivity of R7.
But you see the connectivity of R7 via R1.
Via R1, yes.
Yeah, but in R9 we didn't see, let's say, connection of R1 via R7.
Connection from?
R1 via R7.
Yes. R1 to R7. So next stop will be R1 to R7. This will be a neighborship. So you will see for R1 perspective 1, 2, 3 neighbor.
You know what I'm saying? For the R9, when you checked, when you did a show IP routes, we only saw one neighbor. I was wondering why we didn't see, let's say, the R1 via R7 and so on before we did the virtual link.
I understand what you.
The R9, if you can go back to the history, the top.
Okay.
Just go to the top.
Show IP OSPF neighbor. This is what you're saying?
Yes. Then
And
show IP routes.
I will go to R7 router OSPF1. I am removing this virtual link configuration. Okay, so this was before virtual link configuration. So now here show IP OSPF neighbor. You have neighborship with router number 9.
Yeah.
On router 9 perspective, you have neighborship with 7, and the result is show IP route. So it will take time to now clear this update. Clear IP OSPF process. And make sure here on R7 you do not have OSPF virtual link. So you still have virtual link. To show run. Okay, it is now removed. Authentication. Missing authentication. Show IP OSPF neighbor. Let me remove
So
this.
that's why we are still on R1.
Yeah. Section. Okay, now the neighborship is down. So if I go for now R9, oops, if you go for R7, show IP ospf neighbor, so you don't have any virtual link neighborship.
And we don't even see R1. Okay, R1. Wow.
Show IP ospf neighbor. I still have neighborship. Reason being, this is configured with area 3. So this link is the member of area 3. So area is configured. OSPF is configured between 9 and 7.
And
But since
we can still ping the rest of the network.
in this case we cannot ping because this is the discontiguous area. We don't have any root. And still you will see the root. Let me clear this. Clear IP OSPF process. Show IP OSPF database. We still have databases available. And what I will do here, I will remove the process. Gig 00. No IP OSPF 1 area number 3. You don't have any neighborship, and show IP OSPF database. You have type 5 LSA which is coming from external, and there is also default route which is advertised by the router 1. Clear IP OSPF process. Show IP OSPF database. Now it is database is clear. Go to the link and configure this link with area 3. It will discover neighbor. So neighborship is up. Show IP OSPF database, and now it will see how it is able to see now. Area 3 and rest of the network also. All network is available.
So then I should be able to ping.
And then you can ping. If root is there, you can ping. But it says okay. It has the database. And you don't have external. Let me ping 888 because you don't have now the virtual link. So this is what is happening. Earlier we have configured virtual link, it learn update, and now it is maintaining database because it will take time to refresh. After 1 hour it will ace out all the information from the database table. But the result is that you have no connectivity. Go back to R1 and do show run section router OSPF 1 1 and say no to this command. It says loading is done. Go back to R7, do show run section router ospf, and remove this command no to virtual link. Let's say clear IP ospf process, and for the safe side go to the link which is gig0/1 and say no, or here what I'm saying, to show run interface gig0/1. This is the member of area 3, and even though okay, no IP SPF1 area 3, right now it is not the member of area 3, so you don't have any neighborship pointing to area 3. You have only neighborship with 1. Go to router number 9, see the database, show IP ospf database. See, it will maintain information even though you don't have any neighbors. Clear IP ospf process, and then I will go for interface gig00. We'll say shutdown, and no shutdown. Then say do show IP ospf database. It has only directly connected link. Okay, it's on router LSA. So
It's showing in its own router database.
it's on, yeah, because ospf is enabled on this link. This is correct. ospf is enabled on this link. It's showing its own database information with type 1 LSA. So now do show IP route, because I don't have any neighborship, I don't have any root. I will go for R7 and configuring neighborship on gig0/1 with the command IP ospf1 area number 3. So it will make neighborship between 7 and 9. So now you have the neighborship. I want to see the database first. Show IP ospf database, and see it is still running. So it remembering and keeping the copy. You still have this show IP route, and you have also root, but it cannot ping. But see, the first time when you're configuring virtual link, it will not learn any update until and unless there is no virtual link. The problem with the virtual link is that whatever the update is received via virtual link, those update never will be aged out. It will be permanently stored in your database table, never aged out. So this meaning there is also a problem with the OSPF normal process. With every 30 minutes there is a periodic refreshment.
Okay.
So if there is any error or something is happened with your topology, it is going to be remove the old updates and refreshing with new updates. But now you have a virtual link. The update learned by the virtual link is never aged out. That means this will not, this is what is happening, it is not giving the correct output here, even though there is no virtual link, but very hard to troubleshoot now because virtual link is nowhere. You can see the root is there,
But you can't.
but result is you cannot ping. You cannot ping. And this is, if I see show IP ospf database here, I can see this. If I say show IP ospf database router, and do not H flag. So do not H flag is not visible here. But finally, result is that this is, you don't have any connectivity because you don't have any virtual link. You can see you have a root is there.
Yeah. So I should be able to ping router 1.
Directly connected 172.16 71 dot 17
Yeah.
R9 to 17.1. No, you can only ping directly connected neighbor, which is 71 dot.
7.
Yes, because you have a neighbor 172.71.7. Only directly connected. Show IP ospf neighbor. You can only connect with this IP address. So if you ping here 17.7 17.7, yeah, you can connect this because you're getting reply from, because when the return reply is coming, it is coming from the source address which is known. But if I ping to 71.1, you don't have any reachability.
Why is that? You said there's no direct connection. You said it's because there's no direct connection.
Why it is not learning? This is your question.
Yeah.
See, this is why this problem is happening in the first place. Earlier, virtual link was up. Virtual link is learning all the information. Whatever the information learned by the virtual link is never is out. Now we have removed the virtual link, but since the learning update is never is out, still there is a database, still there is a root, but there is no communication. Because this area is discontiguous area. A rule for the OSPF: if the non-backbone area is not connected with backbone area, you do not have connectivity with rest of the network.
Okay. Alright, so in that similar scenario, without having connected the ARGRP, let's say, assuming that last end, alpha and alpha connecting to R6 was not set up as an ARGRP, that would also have been a disconnected area.
Yes, if router 6 is the member of, let's say, other OSPF,
Yes.
and is configured with OSPF area number 3, so now the router 6 is discontiguous.
So
That area is
one
discontiguous.
also would not have been able to.
No connection, no
Okay.
communication, because this is totally isolated,
Okay.
because you don't have the connection to the backbone area.
Okay. I think I'm now getting the definition. So that's the main reason why.
Yeah, so see, the
Alright.
transit area can only be your backbone area, which is configured with area 0. In this case, area 1 is not a transit area. So area 1 cannot send update to area 0 from the non-backbone area. from the area number 3.
Area 1 is not a transit area.
Yeah, so the only the transit area in the OSPF network is backbone area, which is exchanging update from other area, from area number 1 to area number 3. Those updates is exchanged with area 0.
Area 2. Okay.
Now this is where the rule is that all other area must connected with backbone area. And here the communication is not possible because we don't have virtual link.
Yeah. So once we connect a new virtual link,
There is no communication.
So once we connect the virtual link,
Then the communication will resume.
Until we get the physical medium to make it stable or to make it secure.
Then
Until that will be temporary, so we get a physical link to connect to our backbone area.
that is a permanent solution. Yeah,
Possible, yeah.
if possible. If it is not possible, then we stick with that virtual link solution here. So do show run section router ospf1. So this is the AVR, and you have this virtual link, but there is no authentication flag. Area 1 virtual link 7.7.7 and message digest key number MD5 and Cisco. Go to R7, say area, okay, under the OSPF process, router OSPF1 area, transit area is area 1, right? You are making a connection to area number 3, but the transit area is area 1. Area 1 virtual link, router ID of the next AVR, and first you need to be set message digest flag, and the second is need to be configure message digest key MD5, and this will be your Cisco. Soon you will see neighborship should come up. So neighborship is up, show IP OSPF neighbor. There is a virtual link on router number 9. You'll see the route information here. There are many routes coming now, and ping 88888. So now you have reachability and 6.6. So until and unless if there is no virtual link, or the discontiguous area or the non-backbone area is not connected with backbone area, that is totally isolated from the OSPF network. So this is, you have the OSPF, and I can now
3 hours.
3 hours, yes, stop this.
Yeah.